So I'm going to demonstrate how to do a stoichiometry problem for one of each type. From the slides of notes, you can see the first thing we have to do is write a balanced chemical equation. And to get that balanced chemical equation, we have to have formulas for every single thing in the chemical equation. So when it says lead will react with, we'll write Pb. And as long as this is probably at room temperature, we could put a little solid there if we wanted to. Will react with, and then hydrochloric acid. We didn't specifically learn how to name acids, but that would be a compound dissolved in water that oftentimes starts with an H. And the rule is if it's an hydroic acid, the ion that makes that was the ide ion. So Cl would be the chloride ion, that's a -1, joined up with hydrogen, which is a +1. And that is dissolved in water. And this should be one of the chemical formulas on the back of your periodic table, listed under the common acid section. So here would be hydrochloric acid. And it's going to react in a single replacement reaction and form lead 2 chloride, so PbCl. Lead is a +2 because of the Roman numeral 2. Chloride's a -1, so then we need a 2 here to balance that out. And it's going to produce hydrogen, and anytime you write a single element by itself, you want to double check whether it's part of the diatomic series or Brinkelhoff series. Sure enough it is, and hydrogen would be a gas. Now, we have all of the chemical formulas written. Now we want to balance that equation because there's 2 chlorines here. We'll want a 2 here to get 2 chlorines, 2 H's, and now that chemical equation is balanced. As you're working on these, you can't do any of the math until it is a balanced chemical equation. So if you turn ahead a couple pages, I show you the unbalanced chemical reaction and then also the balanced chemical equation. So you want to double check these. You don't actually want to just look here and copy down these equations. You want to get the practice from last unit, writing those equations, writing the correct formulas, balancing those equations. But once you do that, it's really important that you check your work and make sure that the answers are correct, because if not, then that is really going to mess up your stoichiometry. Now, I highly recommend writing down what you want to know and what you do know. It says how many moles of hydrochloric acid. So I'm going to put a question mark with a moles right there, are completely needed to react with 0.36 moles of lead. So we know what we know and we know what we want to know. And because both of these are in moles, we can do this in one step. That's at the center of our mole map. If you look on the mole map page, if I'm going to switch from one chemical lead to another chemical hydrochloric acid, you have to be in moles of both. That way you can use the moles of the balanced chemical equation. So let's go ahead and write our fraction work. We have 0.36 moles of lead. It's really important that you have a number, a unit, and a chemical label. We're going to cancel moles of lead, and we're going to go to moles of HCl. And again, the only time you can switch chemicals is if you're in moles. This chemical equation says 1 lead will react with 2 hydrochloric acid molecules. The lead cancels, and this math is going to tell us to double the answer. 0.72 moles of HCl. So, because some of these problems can be a little bit more challenging than some of the previous problems we've done, I put the answer key a couple pages over so that you can check them. And a good chemistry student will go back and try to find the mistake in their work at least 2, if not 3 times. And then if you still can't figure it out, star that one and we can go over that when you get back to class. So that is a mole-to-mole conversion. That's pretty much our easiest type of stoichiometry problem because it's in moles and it's converting to moles, and we can do that in one step.